Okay, so we're going to do a number of hypothesis testing examples. So if you remember the steps, the first step is, this is more formally, state H0, H1, and the claim. Step 2, okay, now there's actually 4 steps when we're doing it more formally, okay. Determine your critical values. These are your cutoffs. Z or T values. Okay, we'll be using T values if we don't have the population standard deviation. Step 3, calculate the test static. Okay, so this is Z test or T test. Okay, this is converting your sample mean to the Z table or the T table. And step 4, make your conclusions. Which means, do you reject the H0 or not? Do you accept the claim? Or not? Okay, this is the formal process for all hypothesis testing. Now let's do a number of examples. Okay. Pizza shop claims to deliver in 1 hour or less. Okay? This claim is tested with a significance level of 0.05 and the following study results. Sample mean sample mean is 52 minutes. Standard deviation, population standard deviation is 3 minutes. And sample size for this study was 50. Okay. What are the results? So we just go through these steps. Step 1, state the null hypothesis and the alternative hypothesis. Now the null hypothesis always has to have the possibility of equality, right? So it has to be something is equal to something, or less than or equal to, or greater than or equal to. H1 is the opposite. Either not equal to, or strictly less than, or strictly greater than. Whatever would reject the null hypothesis. So in our case, the pizza shop is saying that the population mean is less than or equal to 60 minutes. That's their claim. Which means the alternative hypothesis must be that it's more than 60 minutes. And that's it. That's step 1. Step 2, we determine our critical values. So if we look at our distribution of sample means, where we're assuming that middle is mu equals 60, what would reject our null hypothesis? Well, that's a value too big. Okay? How big is big enough? Well, such that the area under the curve is 0.05, or 5%. Okay? That means if we have a sample mean that's in this range, it means that there's only a 5% chance or less of observing a value that big, so we're going to reject our null hypothesis. Okay? And we have to determine, well, what is that critical value? Notice there's only one tail this time. There's no tail on the negative side, because there's no value too small to reject the assumption that mu is less than or equal to 60. It could be negative 60, okay? It delivers the pizza, goes back in time, delivers it an hour ago. That's still not too small. That's still less than or equal to waiting for 1 hour. So there's no value too small that'll reject our null hypothesis. Only values too big. That's why we only have a positive rejection region. So, what is that critical Z value that cuts off 0.05 of the area under the curve? Well, we find it on the Z table because we know the rest of the curve must be 0.95. So we just find 0.95 on the Z table. And we have two values that are equally close, corresponding to 1.64 and 1.65. So we're going to take the midpoint between them, which is 1.645. That's going to be our critical Z value. .645. And that's step 2. Step 3 is we calculate our test static, which is just the sample mean on the Z scale. Okay, we fill in these values. So our sample mean is 52. Standard deviation 3, sample size is 50. And remember, we're assuming that it's equal to 60 or less. Okay, 3 divided by root of 50 is 0.42 for sticking to 2 decimal places. And then on the Z scale, that's a negative 18.86. Very far in the negative range. Right, so that test static, that test static is somewhere way over here. Okay, so definitely we are not in the rejection region. So we're not going to be rejecting our null hypothesis. And that's step 4. Null hypothesis not rejected. So our claim is supported. We're sticking to the null hypothesis, so we're supporting the claim. Now remember, last time we actually rejected our null hypothesis, so our claim was not supported, because our claim again corresponded to that null hypothesis. Okay. Now let's do another example. Okay. So let's go with the same situation. Pizza shop claims they deliver in less than 1 hour. Now notice the claim is worded a little different here. So now the claim is that it's less than 60 minutes. Not less than or equal to, but less than 60 minutes. Well, that's an alternative hypothesis because there's no possibility of equality here. Okay? And our null hypothesis is going to be the opposite of that it's greater than or equal to 60. Okay? So now we're starting off assuming that they deliver in 60 minutes or more, and we're seeing, is there enough data to reject that null hypothesis? Okay? And let's say we're going to have the same significance level, and our data looks like this. Sample mean of 56 minutes, sample standard deviation of 4 minutes, and a sample size of 20. So notice we have a sample standard deviation, which means we're going to be using the t-table instead of the z-table. So from our sample size, we also have to determine our degrees of freedom, which is just sample size minus 1, which in our case is 19. Okay? So, our step 1 is completed right here. Our step 2, we're going to do now. We have to determine our critical t-value. Okay? So, in our distribution of possible sample means, where we're assuming that center is 60, we only have one rejection region, which is going to be too low. Okay? Do we have a sample mean sufficiently lower than 60 for us to reject our null hypothesis? And that cutoff is going to be a critical t-value. So we have to find it on the t-table, looking for a tail size of 0.05 and 19 degrees of freedom. So we go to our t-table, and here we have one tail of size 0.05. See, one tail. Now most t-tables will only give you define the columns based on the size of one tail. This particular one defines the columns based on one tail or two tails or the confidence level. Most t-tables will just give you the size of one tail on top. And then we find our degrees of freedom, 19, which is right here. We match the two up. And there we have it, 1.729. Now the t-table will always only give you the positive value. You have to figure out, are you dealing with a positive or negative value? So that 1.729, in our case, we know it's negative 1.729 because in the middle, t is equal to 0 by definition. So because we're on the negative side of that center, we must have a negative t-value. That's step 2 completed. Now we go on to step 3. So we calculate our test static, which is just converting the sample mean to the t-scale. And so our sample mean was 56. and we're assuming that 60 is the population mean. Our standard deviation was 4, and our sample size was 20. Four divided by root 20 is 0.89. And this gives us negative 4.47. So negative 4.47 is very far into that rejection region, right? It's much smaller than negative 1.729, right? So we do reject our null hypothesis, and this is our step 4. Null hypothesis rejected, and our claim is supported, right? Because our claim was attached to our alternative hypothesis. Okay? So if we reject the null hypothesis, it means we're going to go with the alternative hypothesis, which means we're going with our claim. Our claim is supported. And that's an example with a negative tail and a t-test. So we did an example with a positive tail. We did an example with a negative tail. We did an example with 2 tails. Okay? We did some with the t-test, some with the z-test, right? Using the t-table, using the z-table. Remember, if you have the sample standard deviation, you use the t-table. If you have the population standard deviation, you use the z-table. Now, we're going to do a 2-sample hypothesis test. Okay, so this is when you're actually comparing the difference between 2 different samples. And in this situation, there can be paired samples and not paired samples, right? So paired samples are ones where every element in one sample is tied to an element in another sample. For example, you're looking at the same group of people before and after. So for example, let's say you're looking at height between students when they are 11 years old and 12 years old, to see, did they grow? Okay? So you're going to have a bunch of numbers for different people, okay? So we're just going to use numbers instead of names, and so on. So maybe one person started off as being 5 feet, and then later on they were 5.2 feet. Okay, and the second person started off being 5.3 feet, and then they ended up being 5.5 feet. Okay, maybe person 3 started off as being 5.2 feet, and they didn't grow at all. They're still 5.2 feet. And you look at the differences. Okay, so you notice every element in the first table for 11 years is tied to a particular element in the second table for 12 years because it's the same person. We're comparing that 5 only to that 5.2. We're comparing that 5.3 only to that 5.5. We're comparing this 5.2 only to this 5.2, and so on. So we're looking at those differences. Okay, so here the difference is 0.2. Here the difference is 0.2 again. Here the difference is 0. So it's these differences that we're interested in. So for this kind of paired sample, we are interested in the average difference, the standard deviation of the differences, and the sample size, which is going to be the number of comparisons made here. Okay? So for example, it is assumed that students grew from 11 to 12 years old. And we're talking grew as in height. Obviously they grew, they got older, right? So use alpha equals 0.9 and the following data to test the claim that they grew. Okay, and so the data was that our not sure what's going on there. Our sample difference, okay, sometimes you'll see it written like this, the sample mean of the difference is 0.3 feet, okay? The standard deviation of our differences was 0.1 feet. And our sample size, the number of students we looked at, let's say it was 10, okay? Now we're going to be using the t-table because we have sample standard deviation, so we'll also need our degrees of freedom, which is going to be n minus 1, which in this case is 9. Okay? So, step 1, state our null and alternative hypotheses and the claim. Well, so the claim is that the population mean of our differences is greater than 0, right? So it's assumed that they grew, test the claim that they grew. So it's claimed that they grew. So that difference is greater than 0. So our null hypothesis is going to be that they didn't grow. That difference is either 0 or less than 0. Okay? And that's step 1, done. Now, some forms of hypothesis testing show that the null hypothesis is always an equality, not necessarily an inclusive inequality like we have now, less than or equal to, but strictly equal to. The process is the same. It's just when you record it, when writing down your null hypothesis in step 1, it's different. So there's two different forms of conducting hypothesis testing, but it is the same process. It's just the difference of how you write it down. So our step 2, we want to find our critical t-value. So if this is our distribution of sample means, there's our center, where our population mean is assumed to be 0. Okay, we're only going to have a positive rejection region, right? Because our alternative hypothesis refers only to it being greater than 0. And it's going to be size 0.1. Because we have alpha here, you know what? I put 0.9. I meant 0.1. Okay, I was thinking 0.9 is the rest of it. So 0.1. Okay, that's the size of our tail. And we know our degrees of freedom is 9, so now we can find our critical t-value on the t-table. We look for one tail, size 0.1, there it is. And we find degrees of freedom 9, and when we match those up, There's our value, positive 1.383. And we know it's positive because in the middle, t is equal to 0. And we're on the positive end of that, 1.383. Then step 3, we calculate our test static. Which is just the sample mean converted to the t-scale. So we check our values. Our sample mean was 0.3, and our sample standard deviation was 0.1. And remember, we're looking at the differences, right? So our sample mean of the differences, our population mean of the differences, our standard deviation of the differences. So 0.1 over root 10 is 0.03, and 1 divided by the other gives us 10. Okay, now this is all going by 2 decimal places. So if you went for 3 decimal places, you might have a slightly different number. But in any case, you're going to have a number, if you did it right, that is much, much bigger than that cutoff value, than that critical value. So we are in the rejection region, so we're definitely rejecting our null hypothesis. And that's step 4. H0 rejected. So our claim, which in this case is attached to the alternative hypothesis, right? Our claim is supported. Okay, so that's for paired two-sample hypothesis testing. There's also independent two-sample hypothesis testing. Okay, so for independent two-sample hypothesis testing, rather than having 2 samples that are actually tied together, for example, you're looking at the difference of the same person, their height, we're actually looking at 2 completely different populations. Okay, so for example, you might look at who is skipping more class grade 9s or grade 10s. Okay? We're going to use a significance level of 0.01, and we have the following data. Okay? For number of classes skipped. So for the grade 9s, we have a sample mean, and let's say we're looking at it over the course of a month. Okay, for the grade 9s, altogether, there have been 20 classes skipped, with a standard deviation of 3 and a sample size of 50. And for the grade 10s, there's a sample mean of 24 classes skipped with a standard deviation of 8 and a sample size of 80. Okay, so we have two different sample means, two different standard deviations, two different sample sizes, which means we actually have two different degrees of freedoms, 49 and 79. Okay, and we need to compare these. So the difference here is going to happen when we're calculating our test static. So we're seeing if there's a difference between the two values. So when we write our null and alternative hypotheses, okay, one of them is going to say that the population mean for the grade 9s minus the population mean for the grade 10s is equal to 0. No difference between the two. The other will say that the difference between the two is not equal to 0. And of course, the first is our null hypothesis. The second is our alternative hypothesis, because that null hypothesis has to have that equality. And let's say it's claimed that grade 10 skip more. Sorry if you're in grade 10 watching this. It's just for the sake of study. Okay, so we're claiming that there is a difference. You know what? Let's change this. Let's say it's claimed not that grade 10 skip more. It's claimed that there is a difference. Okay, there we go. So our claim is right here, that it's actually not equal to 0, this difference. So then step 2, we want to find our critical regions, right? So that population mean in the middle, we're assuming it's 0. And if you recall, our alpha was 0.01. So half of that is going to go here, and the other half is going to go here. In our degree of freedom, now in different situations there's different ideas of what your degree of freedom should be, considering the fact that you have two different sample sizes. A common way of handling this is going with the smaller value, a chain being as strong as its weakest link. So we're going to go with our degree of freedom of 49. This is the smallest one. So degree of freedom is 49. So on the t-table, we're going to look for degree of freedom 49 and a tail of size 0.005. So there's our t-table. There we have one tail of size 0.005. Notice that corresponds to two tails of size 0.01, which is our significance level, right? And then we look for 49, and you see there is no 49, so you pick what's closest to it, which in our case is 50. And there's our value right there, 2.678. So on the positive side, 2.678, and on the negative side, negative 2.678. Then we do step 3. So the equation for test static is different when we're comparing two different samples that are independent, right? So we actually have to do this. That's what the equation for test static looks like. And in our case, we're using sample standard deviation. For a z-test, which this isn't, but if it were, then we would be using population standard deviation. Okay, so back to the t-test, which we're doing here. Okay, so our sample sizes were 20 and 24. And our first standard deviation and sample size, sorry, our sample means were 20 and 24. Our first standard deviation and sample mean were 3 and 50. Sorry, that's supposed to be a plus sign at the bottom. And the second one was 8 and 80. Oops. Okay, so we have -4 divided by (9/50) plus 64/80. Just going to put that Z1 in a box there. -4 divided by -4.04. So that is our test static, and if we look, that is far into our negative rejection region. Right, so our null hypothesis is rejected. The rejection, the direction it's rejected in is actually that the grade 10s are skipping more. Okay. So H0 rejected, and the claim is supported. Right, and that claim is supported again because it's attached to our alternative hypothesis in this case, and we rejected the null hypothesis. Right, so that's all the kinds of questions you could have for hypothesis testing.